identify, it says identify the segment bisector of line ST and then find ST. Okay. And then,
I need a picture of that, I think. In other words,
all right, how can I send you a picture of that?
just take a picture with your cell phone and send it to my email address. You know how to do
Alright.
that. And let me write my email address. Most geometry problems are going to be difficult to verbalize. In other words, anything that has a graph or a picture of some graph or something, you're not going to be able to verbalize it.
Alrighty.
And so the best thing to do is to figure out what you want to work on, take a picture of it and send it to me before the session, and then we can use the full half hour.
Yeah.
Okay.
Alright.
Let me know when you've sent it.
Alright. Let's see. In the recording of yesterday's session, I didn't get that in my email. Is it going to be going to my mom's email or mine, do you know?
I don't have your email.
No? Okay.
Your mom's is the only one I had, so I sent it there. If you want me, well, you don't need that. In other words, you have that link now, right? And
what link?
The link to the recordings?
No, I don't have it. It's on my mom's email.
Well, have her forward that to you. Then you'll have it. Save that link, and these recordings are always on that link. That is my YouTube channel. That's where I post all my recordings for everybody. You just have to find it by looking for your initials and the date of the session. So it's always going to be a BG and then month, day, and year.
All right.
So they're easy enough to find once you find the first one. Or actually, you know, you can just go to YouTube/digital math tutor. That's the same site.
Oh, okay.
Just youtube.com/digital math tutor, I believe, will get you to that same link.
Okay.
And it'll show you all kinds of videos on there. In other words, yours is probably now down about 7 spots from where it was when I first posted it, because I've had others that go in front. So you kind of have to search for your file when you get to that site. But
all right, let's see. It is sending right now.
okay.
It's almost there.
How many pictures? Just one?
It's 4.
That takes quite a bit longer time to get to me when there's 4 pictures attached. Just the way that the email systems work is if there's a lot of attachments, it slows it down. So one way to do it so that we're not wasting time is for you to take a picture of the very first page, send that to me, and then in a follow-up email do the other 3 pages. And that way I'll get the first one almost immediately and we can go to work on it.
Alrighty.
Okay. I noticed that I still haven't gotten it, and it might take a minute or so to get to me because of the 4 attachments. Now, the next time you send something to me, it'll be a lot easier because all you'll have to type is DA and it'll pop up with a default that you can choose. So
yeah.
You don't ever have to type out my full email. Why don't you try it real quick? Take a picture of the very first thing you want to do, just one picture, and send that to me again. And it wouldn't surprise me if that second one gets to me before the first one does.
All right, let me see.
You sent it to David Cowan 1949
Yeah,
at gmail.com.
typing it in right now.
What I'm saying is you shouldn't have to type it again.
Yeah. Okay.
And in fact, that could produce a problem. In other words, if you misspelled it the first time, say you used W-E-N instead, and now you retype it, there I got it. Now you retype it correctly, well, the next time you send something, both of those are going to pop up. And you're not really going to know which one to use. So it can be a little problematic if you happen to send something to me that where the email is misspelled or something. Because unless you know how to take those out of your default list, I don't know how to do that. So, all right, let's look at some of these here. Identify the segment bisector of ST. Then find ST. Okay. Why do we know that M is the midpoint?
Because the two little slashes on each side.
That means that that line segment's the same length as that line segment. So now what can I do in terms of writing an equation that I can solve? In other words, I see variables. Variables means I'm going to need an algebra equation. So what is it?
It would be x plus 12 equals 8x minus 2.
Okay, now solve that.
That's like what I was having like a trouble with. I couldn't really figure out how to solve it.
All right. We need to put our variables on one side and all of our numbers on the other. That's the way you solve a linear equation. Okay?
Yeah.
So the first thing I'm going to do is subtract x from both sides. Okay, so I subtract an x from there, I subtract an x from there. What does that give me? That gives me 12 over here. 7x minus 2. Now all I have to do is get the 2 on the other side.
Yeah.
By adding 2. You always do the opposite of what it's doing. So now I get 14 equals 7x. What's x equal to?
Pardon?
If 14 equals 7x, what is x equal to?
2?
And now, what's the length of ST?
Well, we would need to go like back and figure that out.
Yeah.
So, would it be 14?
Well, the left side would be 14. In other words, SM would be 14. And we know that MT is also at 14, right? They're the same length. So you don't actually have to plug in the 2 on this part of it. And let me use this pointer. I know you can see this. So once we've plugged the 2 into this part, that says 14 plus 14, 28 is the length of ST.
Okay.
Okay. All right. problem number 2 is
Well, I figured out that one, so.
okay, I was going to say it's just a triangle problem disguised as a word problem.
Yeah.
In other words, no different than if I just drew a triangle and dimensioned it and I said, what is this dimension right there? That's what it's asking for. Okay. And you use the Pythagorean Theorem like you did and came up with what, 4.03, which makes sense. It's always a good idea to make sure they make sense. In other words, we know the hypotenuse is always the longest side of a right triangle. So if I were to come up with a number greater than 4.5, that means I made a mistake.
Yeah.
All right. I don't see a 3. Am I missing a 3 and a 4?
Yeah, his numbers are all kind of spread out.
So what do we want to do next?
Number 5.
Okay. These are relatively pretty easy.
Can you pull up like graph paper on your thing?
I don't need to. In other words, they don't want you to graph it. They want you to say what the point is. Okay. Well, if x comma y is going to turn into x plus 1 comma y minus 3, and my x and y are 5 comma 9, what does that turn into?
6 comma 6? Okay.
It's as straightforward as that. And how about number 6? In other words, what does minus 3 minus 8 turn into? After the translation.
Would that be -2? And -11? Oh, okay, that's pretty easy.
Yeah, no, those are very easy. Let me check.
I sent you.
Let me check my email and see if I got your original one. I did. And this must be the one that has all 4. Oh, did you just send them one at a time, maybe?
Yeah.
Okay. That's fine. Okay. Okay. Here they do want to graph it. It says graph the triangle. Okay, well, I can do that relatively easy without graph paper. Here's my axes. Okay. J is at 2 comma 3, and you can always do this. You can always kind of approximate it. It doesn't have to be super exact. That's point K. Point K is -2 comma 1, so point K would be right there. -2 comma 1, that's K. And L is -1, 5, which is about right there. Biggest thing is just make sure they're not way out of whack.
Yeah.
Okay, so that's L. I'll connect the 3 points of the triangle. And there's my triangle, kind of. Okay? Now, let's do these translations. Hold on, what does it say? Okay, and its image after the glide reflection. Okay. Well, every x point is going to go down by 1. Every y point is going to stay the same.
Uh-huh.
So what's K, the new K?
Well, would it like, so say if K, so the Y would stay the same, so
Uh-huh.
wouldn't the signs just be switched?
Well, not yet. Let's do these one at a time. Let's do the translation first and then the reflection.
Okay.
Okay? Just because it's kind of easier to see that way. Even though in
Alright.
reality you always do reflections first. But I don't think it's going to matter here. It might, but we'll take a look. Let's do the translations first because that's the easiest. So what's K prime? What are the K prime? That's the way you
I would,
do it, is you use a prime to mean the translated point.
yeah, wouldn't it go over one to
Well,
the left?
do the same thing we did on the last two problems. In other words, the x coordinate is my,
Okay, so then it would be negative 3 comma 1.
you got it.
Okay.
What's L prime?
Negative 2 comma 5.
And finally, what's J prime?
1 comma 3.
And if we connect those, you'll notice the triangles look very similar. They haven't changed shape. It's called a glide because all we really did was we took the triangle and glided it left by 1 unit, right?
Yes.
I didn't change anything else. Now let's reflect it over the x-axis. So what is my
Okay.
real, let's do this in green. Okay. So we'll call this K double prime, just because we're doing it uniquely. You would never do it like, you wouldn't use K prime and K double prime. You would just use K prime as your final point. But since we're doing it in steps, I'll use the double prime. What is the dimension when I flip that point over the x-axis?
Negative 3 comma negative 1.
Yeah. And L prime?
Negative 2 comma negative 5.
Or L double prime? Negative 2 comma negative 5, yes. Negative 2, negative 5. And what's J prime?
Negative 2 comma negative 3.
Now, start from the red, because we've already translated
Oh.
1.
Oh, I mean negative 1 comma negative 3.
It's not negative 1, it's just 1.
Oh.
In other
Okay.
words, the x-coordinate never changes when you're doing a reflection over the x-axis. The x-coordinate stays the same, right?
Yeah.
So it's going to be 1 comma negative 3. So there's J prime, or J double prime. And coordinate is 1 comma negative 3. We're operating off the red. And now if we draw that triangle, that should be a perfect reflection of the red. Okay? And you'll kind of notice that had we done the reflection first off the black, wouldn't have changed anything. Right?
Yeah.
In other words, we're going to change the sign on the y-coordinate.
Yeah.
The 1, the 5, and the 3 all become negative 1, negative 5, negative 3, but the reflection doesn't affect the x-coordinates. So we could do the reflection first and then shift everything 1 to the left, which changes all the x-coordinates. But you still end up with the green. Okay? But probably it probably is a better way to go by doing your reflections first. Because
Okay.
there are some functions where if you do the reflection last, you get a different looking graph,
Yeah.
depending on everything that's going on. They did these simple enough that the graph is the same regardless of whether you do the translation first or the reflection first. But
Uh-huh.
in most math problems, you're always going to want to do the reflection first.
Yeah.
So let's do that on this problem here.
Um, since we have like only like 10 more minutes left,
Uh-huh.
um,
Would you rather do a
can you
different
just,
one?
pardon?
Would you rather do a different one?
Well, no, I just want, like, could you just, like, give me a quick, brief explanation on when it says reflection in the line x equals -2?
Sure, sure. All right, let me go back and redraw my points. That's 2, 3. Sorry, I should have just used the other page. The other is -2, 1. And the third point was -1, 5. So let's do the reflection first, and I'll put that in red again. Oh, hold on.
Okay.
See, this is, that's J. Whoops. And this is K, and this is L.
Mm-hmm.
So in red, we'll do the reflection. Where's the new L?
I'm not sure.
The only thing that changes when you do a oh, excuse me, sorry. My apologies. We're not reflecting over the x-axis. We're reflecting over the line x equal -2. Well, let me draw that as a dotted line. And I know it goes through that point because that's the x-coordinate, right?
Yeah.
Okay. So the way you reflect here is this is like a reflection over the y-axis because you're reflecting over a vertical line. So it's a lot different than reflecting over the x-axis, which is a horizontal line. Makes it seem the same, but it's not. Okay?
Mm-hmm.
So let's take point J. J is how far, the x-coordinate of J is how far away from that line?
I'm not sure.
4 units. There's 2 here, 2 more there. You see that? You see
Yeah.
the x-coordinate is 2, and we're reflecting over the line -2. So that J has to go 4 units to the left of that.
Uh-huh.
What's the coordinates on J now? In other words, it's 4 units away from that line, right?
Yeah.
That distance is 4 units. So it's got to be 4 units to the left of that line, which gives its x-coordinate as what?
Maybe 6 comma
-6.
-6 comma 3?
Yeah, the y-coordinate didn't change. So that's A single prime. We're going to do these one at a time again. We're doing the reflection first. Let's erase this so we don't get mixed up.
Well, that's like all I wanted to know because I just didn't know how I would do the negative.
How does K reflect? K's a little bit strange. Where's K prime going to be?
Wouldn't it just go on the other side?
Same spot.
Yeah.
That's K prime also, because we're reflecting about the line that it's already on. So
Yeah.
0 distance from that line. Well, after I reflect, it's still the same place. It hasn't moved any.
Uh-huh.
About L. how far is the x-coordinate on the original point L away from that line?
It would go to -3, wouldn't it?
Yes.
All right.
So
Say
the
we could probably.
point is on that is -3, 5. Okay, so we've got our reflection taken care of. Now let's do the translation. Add 2 to every x-coordinate, subtract 3 from every y-coordinate. And I'm going to put this in green. So where is the new j double prime?
The new j double prime. I don't know.
Add 2 to the x-coordinate and subtract 3 from the y-coordinate. What do you get?
So it would be -4, 0?
Yep. So there's j double prime, and that's -4, 0. About L double prime. Add 2 to the red number, subtract.
So negative.
Go ahead.
1, 5 or 2?
Yes. -1, 2, which puts it right about there. -1, 2. And that is L prime. And the last one to do is K prime. And we're reading the black because the black is the same as the red. Whoops. So let me just put that in red. Okay. Now, add 2 to that. Subtract 3 from the y. Where do you end up?
I think you end up at 4, 0?
Well, I'm adding 2 to the x-coordinate. When I add 2 to that, I get 0.
Oh, on the green. Sorry.
Well, yeah. Well, we're working from the red. In other words, the red was our reflection, and now we have to translate that reflection. So I'm going to add 2 to the x-coordinate, which makes it 0. I'm going to subtract 3 from the y-coordinate, which makes it -2, which puts it right there in green. Hold on. And that is 0, -2, and that is my new K prime, or K double prime. So I think we got them all. We got J double prime, L double prime, and K double prime. So this triangle would look like that.
Yeah.
It's kind of confusing to do it all in one step. In other words, to do the reflection and the translation in one step can be done. Clearly, we didn't have to do it one at a time, but you just got to keep everything straight. And this was not that easy to do. Because we were reflecting over a vertical line x equal -2, it was a little tougher than either a reflection over just the x-axis or the y-axis. Typically, you're just doing over one axis. All right. Let me just have a quick look at this number 5. Maybe I can.
I'm good with number 5.
Okay. Cool.
I don't need help on that one. Maybe a little bit of help on number 9.
Where is 9?
That's on another page that I sent to you.
Okay.
Do you have another appointment later tonight?
I don't, but I can't give you a whole half hour. I can give you just a few minutes to do 9.
Yeah.
Just because I've been working for like 4 hours in a row and I'm starving and need to eat. I don't see.
You might have to refresh the page.
Oh, yeah. I only got 2 emails from you.
Yeah. All right. Well, they didn't go through, but I think I'm good. I mean.
Okay.
Can we find?
Okay.
That's color fun, yeah, for sure.
Yeah,
Alright.
the toughest part was reflecting over that vertical line, okay? If you're not reflecting over either the x-axis or the y-axis, but some vertical or horizontal line, then the secret is to figure out how far away you are, how far your x-coordinate is away from that line, and put it that distance on the other side of the line.
Yeah.
In other words, the 2 became -6 because it was 4 units away from that line, so I got to be 4 units to the left of that line, which puts it at -6. Okay? And that's the way you want to do all of those. And if you're reflecting over lines like y = 2, which is a horizontal line, then you want to use the same strategy. Figure out how far your y-coordinate is away from the line and put it an equal distance on the other side of that line. And usually those kind of reflections only affect one of the coordinates. Notice that this one, when we reflected over the line x = -2, the only thing that changed was the x-coordinate. The y-coordinates didn't change at all. And that's the way it always is. If we're reflecting over a horizontal line, the only coordinates that will change will be the y-coordinates, and the x-coordinates won't change. So that's a fairly important thing to know. Depending on which way your reflection is, it usually only affects one of the coordinates. You just have to figure out which one. Okay?
Yeah.
All right, Brianna, I will let you go.
Alrighty.
And
So can you send these links to my email?
I tell you what, give me your email and I will send you that link again so that it goes straight to you. What is your email?
Alright. Do you want me to put it in the chat?
Yeah, sure. Well, actually, sure. That's probably the best way. That way I can't misspell it. Yeah. Okay, I've got it. Now what am I going to do with it? Let's see here. If I do this, this is what I'm going to do. I'm going to put it into where your mom filled out her email. I'll put it right here and replace your mom's with that one.
All right.
Now, tomorrow after this thing gets processed, I'll send it to this email. I'll send the same link that I sent to your mom, I'll send it to you, and then you'll have it on your computer for good.
Okay.
Okay? Okay.
All right. Well,
Good luck.
thank you very much.
Yeah, sure.
I